Hey everyone, Eti and I are very happy to be here at the Data and AI Summit 2021. But before we start, I want to share some numbers with you. So digital advertising is a multi-billion-dollar industry. In 2019, internet advertising spending worldwide was over $290 billion. Apple spent over $100 million on iPhone and TV Plus advertising during September and October of 2019. And GM is said to be shifting significant dollars to connected TV advertising. So huge amounts of money are spent each year on digital advertising campaigns. That's why everybody wants to measure their campaign efficiency. But how do you do that? Glad you asked. This is going to be the focus of our talk today, funnel analysis with Apache Spark and Druid. So now I can introduce us. My name is Itai Yafe. I'm Principal Solutions Architect at Imply and previously a Big Data Tech Lead at Nielsen. I've been dealing with big data challenges since 2012. Co-presenting with me is Eti Gur, who's a senior big data engineer at Nielsen, and she's been building data pipelines using Spark, Kafka, Druid, Airflow, and more. You can reach us both over Twitter and LinkedIn. So a little bit about Nielsen, and specifically Nielsen Identity, which is the division Eti works for. So Nielsen is a data and measurement company, famously known for measuring the TV ratings in the US, and generally speaking, measuring media consumption. Now, Nielsen Identity has the unique role of unifying many proprietary data sets in order to generate holistic view of consumers. We are talking about anonymous data, of course, and serves as a single source of truth of individuals and households for the broader Nielsen products in order to provide better and more accurate insights. Nielsen Identity, some numbers about us. So there are over 10 billion events flowing into our main Kafka cluster every day. Those events are stored in our S3-based data lake, which stores 60 terabytes of compressed data every day to a total of 5 petabytes. We process the data using Spark and we launch 6,000 nodes per day. And finally, we ingest tens of terabytes of data every day into Druid, which is our OLAP database. So you can probably imagine that this massive infrastructure comes with challenges, and mainly scalability, fault tolerance, and cost efficiency. So what are we going to talk about today? We're going to talk about how to overcome the technical challenges of funnel analysis using 3 Apache tools, which are Apache Spark, Druid, and DataSketches, and why should we even care? So we are talking about advertising campaigns, and we've all been there, right? Browsing the web, clicking different advertisements. So from the user's point of view, the 4 main campaign phases. So from left to right, we have the awareness phase, where a user becomes exposed to a campaign, for example, by viewing an online ad. Then there's the consideration phase, where interest is expressed, for example, by clicking an ad. Then we have the intent phase, where actual steps are taken towards making a purchase, for example, adding a product to the cart. And finally, there's the purchase phase. Internally, we divide those into 2. So the awareness phase is called a tactic, because we essentially have different ways or different tactics to advertise our products. And the other phases are called stages, and we'll touch base on that later. Now, from the campaign owner's point of view, we're talking about massive amounts of users, so maybe millions or billions of users reach the awareness phase, meaning they are being exposed to a campaign. Then after a significant drop-off, we have the consideration phase. After another drop-off, we have some users reaching the intent phase. And finally, if we are lucky enough, we have some users that actually purchase the product. Now, why is it even called a funnel? So take this made-up example. Let's say that 100 million unique users were exposed to an ad. And we'll talk about what's the term unique users later. But say 100 million of those users were exposed to an advertisement. Then after a drop-off, 15 million of them reach the homepage, 10 million reach the product page, and finally 3 million reach the checkout phase. So visually speaking, this resembles a funnel. Now, we need to analyze the funnel, hence funnel analysis. Now, we mentioned unique users, so let's see what that means. Here's another made-up example of an e-commerce website, and you can see we had 7 views across different pages in this website, but those views were made by only 2 unique or distinct users, and that led to only 2 purchases. So you can see that it doesn't necessarily mean that the more views we have, the more purchases we have. That's why campaign owners and website owners care about measuring the number of unique or distinct users. Now, measuring or counting the number of views is a relatively easy task, technically speaking, but measuring the number of unique users is more complicated, and we'll talk about it in the next slides. So remember this guy? Everybody wants to measure the campaign efficiency. But how do we do that technically? So first, we need to collect a huge stream of events, or what we call user activities, while the campaign is live, while the campaign is in progress. Then we need to map those events to funnel stages. Remember that we said that an ad exposure is a tactic, and the other phases are called stages. Finally, we need to provide insights quickly so campaign owners can take active measures toward making their campaigns more efficient. Now, you probably think, well, there are existing alternatives, right? That's true, but there are some caveats or some features lacking in those off-the-shelf alternatives. So some of them lack scalability or have limited scalability. Some of them lack access to the raw data. And some of them, when it comes to count distinct operations, or basically counting number of unique users, do it very slowly. Luckily for us, we have Apache Druid. What is Druid? It's a real-time analytics database, which is all-up engine, very fast, scalable, time series, etc. Now, it's really cool because it can store trillions of events and petabytes of data. It can serve sub-second analytic queries. It's highly scalable and cost-effective, and it has a decoupled architecture, as we'll see in the next slides. Now, I mentioned that Druid is a time series database, so it partitions the data first and foremost by some kind of a timestamp column, like this timestamp column here. Other types of columns are dimension columns, like this website column, where you can filter your data by. And a third type of columns are metric columns, where you can aggregate your data by. All those types of columns comprise of what we call in Druid a data source, which is basically an equivalent to a table in a relational database. Now, Druid has a very powerful feature that's called rollup. If you think about it, we're talking about aggregation queries or an all-up engine, so we don't really care about the raw data, but rather we want to have like the final result. So in this example, we want to know how many views website a.com received for a given date. So what we'll do at ingestion time, we'll use a certain set of aggregators in order to doing ingestion time, meaning while loading data into Druid, we will aggregate the data, and the data will be stored in Druid in a much more compacted, smaller way, which is only the final result. Now, we mentioned that Druid has a decoupled architecture, so let's talk about that. Basically, Druid has three types of processes. It has processes to ingest the data, it has processes to query the data, and it has processes to manage all that orchestration. Talking about ingestion, we can ingest data in real time, for example, through Kafka, into what is called in Druid real-time nodes. We can also ingest data in batch using MapReduce jobs, for example, into a component that's called deep storage, which is essentially a scalable storage like S3 or HDFS. Now, as I mentioned, during ingestion, we're doing some kind of rollup or aggregation, and we store the data in a proprietary file format, what we call segment files in deep storage. Those will be loaded in a background process into a second set of nodes that are called historical nodes, because obviously they serve the historical data. Now, once a client comes in and wants to query the data, it can either use the native query language, which is JSON-based, or send a SQL query into a third type of nodes that are called broker nodes. So a broker will receive the query, parse it, pass on the relevant subqueries to the relevant nodes holding the part of the data, and upon retrieving the partial result, it will make the final aggregation and return the result to the client. As some of you may have noticed, this is basically an implementation of the Lambda architecture. So Druid is used by data companies of all shapes and sizes, like Airbnb, Netflix, the Israeli apps flyer, Nielsen, of course, and Imply, which was founded by the original creators of Druid. It's also being used for many different use cases, like clickstream analytics and funnel analysis, network performance or application performance monitoring, IoT use cases, and all-up, and a lot more. So in a nutshell, Druid is a real-time analytics database, which is time series and column store. It can ingest and store trillions of events and serve analytic queries in sub-second. It's highly scalable and cost-effective, and it's widely used among data companies for different use cases, and specifically the funnel analysis use case, which is the focus of our talk today. Now, why is Druid suitable for the aforementioned tasks? Because, as we've seen, it's highly scalable. It can store trillions of events. And with regards to count distinct operation, it can do sub-second approximate count distinct with set operations. Let's explain what that means. So sub-second is obvious. Approximate means we'll estimate the number of unique elements from a given set of events. Set operations mean union or intersection between attributes or between sets. So for example, a query I'd like to give is how many unique devices were used by female in the US that were interested in technology. Now, Druid does all that using the Theta Sketch model, but we didn't mention the Theta Sketch model, right? So let's see what Theta Sketch is. So essentially, it's a mathematical framework or a generalization of the KMV algorithm. KMV, or K minimum values. K stands for the number of samples we will take from an incoming stream of events. So we will predefine the size of the sample we will take from the incoming set of events. And minimal values refers to the process of selecting those K samples. Now, using that sample, we can estimate set cardinality, or basically estimate how many unique elements are in that set. And it also supports set theoretic operations such as intersection or union. Now, I mentioned that Theta Sketch is an approximation algorithm, so it comes with a built-in error rate. But you can see that the bigger the K value, the more accurate result we'll get. Now, obviously, it's trade-off because the larger the K, meaning the more samples we need to take from the incoming set, the more memory and storage we will need to handle that. But you can see that for K equals 32,000, we'll get around 1% error rate, which is really good for huge data volumes. Cool, time for demo. Cool, so let's take a very low K, K equals 4. And if you follow this error rate box here, you can see that it's gonna be very high, right? It's gonna be dozens of percents. Now, let's take a bigger K, so K equals 4,000, and we'll follow the same error rate box. And you can see that the error rate is about 1 or 2%, which is really good. Cool, so I hope that gave you some kind of intuition of how Theta Sketch works. Luckily for us, there's an actual implementation of Theta Sketch in Druid, which is a part of the awesome Apache DataSketches library originally created by Yahoo. Now, at ingestion time, what happens is sketches, which are data structures, are created and stored in those Druid segment files that we mentioned earlier. At query time, those objects, those sketches are aggregated, for example, union, intersection, or difference between sketches. And the result will be the estimated number of unique entries in the aggregated sketch. So going back to the same example, we can estimate how many unique devices, such as smartphone, tablets, etc., were used by female in the US that were interested in technology. We will share the slides later, but in this video, you can see my colleague talking about Theta Sketch and Druid. Now, just to kind of go back to how we do rollup with specifically count distinct in Druid. So taking the same example, now we want to count how many unique devices viewed the A.com website for a given date. So we will use the Theta Sketch aggregator, which is just a different set of aggregator. And you can see that this device is actually appearing twice, so we only need to count it as one time, as one unique device. And there's another device for the same website for the same date. So we will store the number 2 because 2 unique devices viewed this website in the given date. Now, obviously, we cannot store the number 2 itself because that won't allow us to do set theoretic operations like we mentioned, right? So what we actually store in Druid is a Theta Sketch object. And the actual result is calculated in real time, meaning once the query is executed. And that allows us to do unions and intersections. Cool. Now, Etty will walk us through how to leverage all those tools in order to build funnel analysis pipelines. To you, Etty.
Cool. So back to funnel analysis. The simple use case of funnel analysis goes as follows. How many unique users viewed an online ad versus how many unique users viewed an online ad and also viewed a specific product page. So this is a screenshot from our system that we give our clients, and obviously the numbers are made up. But let's look at an example. Here we can see a tactic is some kind of an online advertisement. And we have around 8 million unique users viewing that ad. And of these users, 3,100 unique users reach the homepage. So let's see how we do it technically. This is our data pipeline, and it starts with our S3-based data lake, holding the raw events data partitioned by date. And since this data is quite huge, as Itai said, 5 petabytes in total and 60 terabytes compressed data per day, we are going to use Spark to process it. So periodically, once a day, we run a Spark application called the Mart Generator that reads the files of the last day, does some kind of transformation to this data, and creates data marts for all the campaigns that are currently running. I just want to mention the term data mart is meant to describe a projection of the raw events, and it can be a subset or a transformation or aggregation. So these data marts are then written back to S3, partitioned by campaign and date. After that, we have another Spark application called the Enricher, which reads the files per campaign, enriches the data, and writes its output back to S3, partitioned by date and campaign. And finally, we load this data per campaign to Druid, our OLAP database. So I want to take a closer look at each of the components. So as I said, our raw event data is partitioned by date, and we have stream of events. And this is a simplified example. Of course, we have billions of events. So we have the event time column, which is a timestamp, the user ID, which is the device ID that performed some kind of action, the attribute, which is the action that's been made, and it can be viewing an online ad, or clicking into a homepage, or a product page, etc. So after the first Spark application is done, we have the results partitioned by campaign and date. And now we still have the event time, the user ID, and the attribute. But now we map these events to the matching stages in the funnel. So an event for online ad will be mapped into a tactic. Homepage will be a stage, and a product page will be another stage. So after the enrichment is done, we end up with this structure. We have the data partitioned by date and campaign. The event date will be now truncated from the time part because we only care about the daily trends of our campaigns. We'll have the user ID, and now we'll have the tactic that's been made and a stage that's been made. So we can see a row of tactic being an online ad and the stage being a homepage, and another row for tactic being an online ad and the stage being a product page. The next stage is to load this data into Druid, and we are using Hadoop MapReduce ingestion task. So the next few slides are describing the specification of this task, and I'm not going to go into the details right now, but what you need to know now, and of course we are going to share our slides so you can take a closer look. But what you need to know now is that we end up with the data in data sources in Druid. When a data source is like a table, and we have a table per campaign, when the schema is the time column, the dimensions columns are the tactic and the stage, and the metric column is the user ID sketch, which is the Theta Sketch object created at ingestion time based on the user ID field. Once we have this data in Druid, we can then query it. So this is an example of a SQL query that returns the estimated number of unique users that viewed the online ad and also viewed the homepage between a certain period of time for a specific campaign. Now I want to revisit the simple use case. And we can see we have a tactic of some kind of an online advertisement that has around 8 million unique devices exposed to it. And now I want to talk about the next phases of the funnel, which are the homepage and the product page. And here we can see we have 3,100 unique devices reaching the homepage, a drop of 2,500 unique users, and 1,000 unique devices in the product page. But if you're paying close attention, you can see that these numbers do not add up. So let's try to understand why this happens. If we go back to what a funnel looks like, it basically shows we have many users exposed to an ad. Some of them continue to the homepage, some of them continue to the product page and then to the checkout. But as we all know, being internet users, is that you can access the product page directly from external sources, for example, Googling the product, and not necessarily going through the previous stages of the funnel. So now our use case gets a bit more complex into how many unique users viewed an online ad versus how many unique users viewed an online ad first and then viewed a specific product page. This is what we call a sequential funnel because the chronological order of events is important. The data pipeline will be very similar, but now we will have to take into account only the events that happened in the predefined order of the funnel. That way we can better represent the efficiency of a specific tactic. We can really know which ad contributed to the campaign success. So if we go back to our pipeline and try to see what we do differently this time. Let's look at an example of the raw event data. We have a user that at 9:15 in the morning is clicking into the product page. After that, at 10 past 10, the same user is exposed to an online ad. And 1 minute later, the user is viewing the homepage. So you can see the user did not really follow the predefined order of the sequential funnel. Our Mart Generator will take these events and map them to the stages of the funnel. So we can see we have a stage happening, after that a tactic, and after that a stage. So our funnel is a little bit broken. Normally, what our Enricher would do is take these events and map them to the following rows. Having the event day, the user ID, the tactic will be the online ad, and the stage will be a product page. And another row with the tactic being the online ad and the stage being the home page. But we all remember that this user viewed the product page before he saw the ad. Therefore, we cannot really say that this ad contributed to the user going into the product page. So this event does not conform to the predefined order of the funnel. So we would want to discard this event and all the events that don't conform and remain just with the events that do. So this Druid query is quite huge, so I'm not going to read it now, but as I said, we are going to share our slides, so you can take a closer look later on. But it returns the estimated number of unique users for the drop-off between the homepage and the product page. And now, when we go back to our screens, after doing the changes in our pipeline, we can see that now the numbers are correct. And they do add up because we eliminated all the events that did not conform with the sequential funnel predefined order. And if we look at it in another way from the funnel point of view, we basically discarded all the events of users going into a stage in the funnel and not going through the previous stages. So that's it for me. And now Itai is going to sum things up.
Thanks, Eti, for walking us through the simple and more complex use case of funnel analysis. I want to share a few tips with you with regards to the technology stack we've just seen. So we described how you can use Druid with Theta Sketch for fast approximate count distinct, along with set operations such as intersection, union, or negation. Sharing the same example, how many unique devices were used by female in the US that were interested in technology. Eti showed you how you can use Spark to pre-process incoming events, which will allow you to take into account only events that happened in the predefined order of the funnel. You can check out her talk, Optimizing Spark-Based Data Pipelines, to get more tips on optimizing your Spark pipelines. And finally, you can further optimize your ingestion process by writing Theta Sketch objects directly from your Spark application and loading them into Druid using this isInput Theta Sketch flag. So what have we learned today? We learned that funnel analysis is very important for advertisers because huge amounts of money is spent on it each year. We've also learned that it's not an easy task to solve technically, especially if chronological order of events matters. We discussed Druid as a very powerful tool for real-time analytics because it's highly scalable, can ingest and store trillions of events, and serve analytic queries in sub-second. And it's being used for many different use cases. And lastly, Etty showed you how by combining these three Apache tools, so Apache Spark, Apache Druid, and Apache DataSketches, can help you mitigate this very complex technical task. So you can pre-process events before ingesting them into Druid and decide how to handle out-of-order events. Great. So just before we wrap things up, a few things we care about. Women in Big Data is a worldwide program that aims to inspire, connect, grow, and champion the success of women in the big data analytics field. There are over 30 chapters worldwide, and everyone can join regardless of gender. So we really encourage you to find a chapter near you using this Women in Big Data website. We have a couple of interesting conference talks. So Yakir Buskila, my colleague, and I are going to talk about Druid in practice in the upcoming Berlin Buzzwords conference in June. There's also a talk about migrating Airflow-based Spark jobs to Kubernetes that my colleague Roy Tevet and I gave in the previous Data and AI Summit Europe. And there's also the Nielsen R&D Tech Center blog, and specifically a post about data retention and deletion in Apache Druid. Cool, that's it for us. We'll be taking questions now. We really appreciate the time you spent with us. And please don't forget to rate our session in the Data and AI Summit website. Thanks, everyone.